Hello everyone, welcome back to our Algebra 2 class. So as I mentioned in the previous video, we are going to do more practices about arithmetic sequence. So before we start, I just want to quickly go over the two key formulas we mentioned on how do we define arithmetic sequence. As I mentioned, the first one, we use explicit formula, which is AN equals A1 plus N minus 1 times D. D stands for common difference, so we can use this one to predict any term in the sequence. For the second one, it's called recursive formula. We use this one to define the relation between any two consecutive terms, which is in arithmetic sequence, we just need to add a common difference to get the value of the next term. So this is how do we define this. So in this video, we are going to practice 3 examples together and to get a better understanding for this kind of formulas and how we use this formula to solve different kind of problems. So let's check the first one. The first one said write an explicit and recursive formula for this sequence. So let's check the first one. So as we mentioned, we have 2 ways to do that, right? One is explicit, one is recursive. Let's use a different color to write it. Okay, so explicit formula, as we mentioned, AN is the first one, N minus 1 times D. D stands for common difference. So all we need to do here, we plug in the value for words we need to know. A1 stands the first term, which is -1. And N will be the variable changing here, can be 1, can be 2, can be 3, can be 4, counting numbers, right? And next, we just need to figure out what is the common difference for this case, which is if you check this carefully, -1 to 1, we need to add a 2, add a 2, add a 2. So clearly, common difference is 2, right? So we just times 2. So that's it. This is our explicit formula. We can also just use the distributive formula to simplify this if you want to. And we combine like terms, so it's going to be -3 plus 2n. And that's it. That's our explicit formula for this sequence. Now, let's check recursive formula. Remember, recursive formula always provide 2 things. What is the first term? And how do we get the next term, which is adding common difference. And that's it. That's our recursive formula. So it's kind of, very straightforward, right? So recursive formula, the downside part for this is in order to find, for example, I want to find a 20th term, and you need to find a 19, 18, like all these previous terms in the sequence. But if you just look at this, it's very easy to tell what is the first term and what is a relation for between the 2 consecutive terms. It's very easy to see all the common differences too. Okay, so that's actually the good part for this one. So that's the first example. Let's move on. So this one says an arithmetic sequence has a common difference, -4. So we know D is -4. Let's write down some key information here. And also we know the 23rd term is 10. Let's write down A 23rd. It's just easy to use this term, this symbol, instead of, the whole sentence. So it's very easy to see. Now we need to find the first term, which is A1. Okay, so since we have this information, so clearly it's easier to we go back to use explicit formula. So as we mentioned, explicit formula telling us in order to get whatever the future terms, we need to add that n minus 1 times for the common difference in order to get that term. So since I know the 23rd term, that means in order to get a 23rd term, I need to do 23 minus 1 times the common difference, which is -4. So basically, I just, plug in the values I know, right? So we know 23rd is 10. We are looking for A1. And this is 22 times -4. So it really look like an equation right now, right? So it's actually plus minus is going to be minus. So clearly, in order to solve for A1, what do we need to do? We have to add 88 for both sides, right? So that's it. Our A1, which is the first term, is 98. So the first term, oh, sorry, sometimes my writing is not just working well. The first term is 98. See, we use an explicit. So this one is quite opposite because, we don't know the first term, but we actually use some, future terms to predict, to go back to check what is our first term. It also works, right? So that's why it's, you can use explicit formula in multiple ways to figure out the answer. Okay, last question. So last question says, Cassie is training for a bicycle race. On the first day of the training, she rides 12 miles. She increased the distance she rides by 3 miles each day. And the first one, we need to write an explicit formula to represent this scenario. And also we need to answer how many miles will Cassie ride on her 9th day of training. Okay, let's solve the question one by one. As we mentioned, explicit formula, let's use a black color so it's tell the difference between the blue. So explicit formula looks like this way, right? So we need to plug in the answer here. So the first day, let's consider this is the first term, is 12. For each day increases, keyword increases 3 miles. So this is indicate our common difference. So now we can just plug in 12 and minus 1 times 3. Again, you can also simplify this by using distributive formula. So it's going to be 3n minus 3 is going to be 9 plus 3n, right? So this is explicit formula is, okay, let's use the red one to write down the final answer is 9 plus 3n. This is our explicit formula. Now, since we mentioned that, let's just quickly write down its recursive formula, but it's very straightforward, right? So recursive formula is the first term is 12, and in order to get the next term, we have to what? As I mentioned, adding 3 miles each day, right? So this is actually recursive. Again, some students might say, but sometimes you use F1 or Fn like this symbol. It's totally fine. If you don't want to use it, or whenever you use recursive formula, you prefer use this, F of n format, that's perfectly fine. It really doesn't matter. So just want to tell you the symbol really doesn't matter as long as you understand the meaning of this. Now, let's work on this. So we are asking how many miles she's going to ride on 9th day. And also the good idea is you can definitely pause the video to think about this question on your own. And also come back to compare your answer with mine. So 9th day, we actually come in talking about, since we know the first term is 12 miles, right? And each day we just adding 3. So some student might say, how about I just keep adding until A9, which is fine. It's not really wrong, but we can definitely, save some time, just use whatever we mentioned here, right? So according to this formula we already mentioned, A9 is gonna be plus 9 plus 3n. So we just need to replace n with 9. So it's because A9, this is the answer here. So it's gonna be, the answer is gonna be 36. So on 9th day, she is going to ride 36 miles. So some student might say, hey, what if I do not simplify here? I just use this one. Is that okay? Yes, you can. So I just use this one, then n is 9. So I'm going to 12 plus 9 minus 1 times 3. So as you can see, 9 minus 1 is 8. 8 times 3 is 24. So 12 plus 24. Did you get the same answer? Yes, you are. So it really doesn't matter. So that's why I said you can simplify this. It's just, shorter and quickly to use. But if you think the structure of this one to make, you feel more understandable, more clear about the sequence, definitely use that. This is just the example to tell you how do we use explicit formula to solve this kind of question, okay? Okay, so that's all the 3 examples today to talk about the arithmetic sequence. I hope this example will definitely help you to understand, well, hopefully it helps you understand the explicit formula and also recursive formula. And if you need to watch it, go ahead, just, review these examples on your own. And I hope you can totally understand, you can totally master this topic. Again, thank you so much for watching this video and checking this topic with me. Take care, everyone. See you soon.